instruction format. Fine. So that is the first type we have just described. The second type, as I said, that we don't use it because we have not discussed about our jump operation. But still, we need to know it, although it's very simple. First one is the operation code, and second one is the, by the way, all operation code is 6 bits. All operation codes are 6 bits. So after the 6 bits was operation, we have 26-bit target, the address of the 26-bit target. Okay, for example, this one. So the J is the opcode. So we have J, JN, JXN, JX. So many types of jump we have, conditional or unconditional. So depending on that, we have the code here and then the address. Just for your knowledge that we do write the jump code in this way, in this MIPS types of processor. Okay, let us see the third one. Third one is the R type register, which is the most common one, the register type, because we know that most of our task has been done in the registers, right? So we have opcode, obviously operation code. We have RS, which is the source register. We have RT. In this time, we call it as second operands. Here we explain that RT is the destination one. Here we call that RT is the second operands, and RD now in extra one, which is now considered as destination register. Fine. And SA and function, we don't need to, worried about. SA always most of the time is 0. And function, it depends on which type of operation code you are using. Based on that, it will have one code. For example, this. So RS is the first operand, RT is the second operand, RD is the destination register, SHAMG is the shift table, is most of the time it is 0, and the function based on the opcode. So let us see. For example, for the add operation, look at the function code is 32. For the add U, it is 33. Sub 34, sub U 35, like this. Okay. So now the example of the code. This is the example of the code of the register type or R type. Fine. So we can see that add, that is the opcode. One register, another register, and another register. Generally, this one plus this one, and the result will be stored here into this register. And we know that all of them are registered because we have a dollar sign. Please remember, whenever you write code in the MIPS or RISC types of processor, obviously you must have a dollar sign before the register. But whenever you use or whenever you write the code in 6 types of processor, for example, Intel processor, you don't need to write the dollar sign. You just need to write the name of the register. For example, EX, EVX, AX, BX, ALH. No need to write the dollar sign. But here, whenever you write any register as a variable, you must write $1 sign. Fine. So if you want to explain the code or rewrite the code in C programming or high level programming, that will be the code A equal to B plus C. In this case, A represents this, B represents S1, and C represents S2. And where you can see that add, we have 3 registers, right? RS, RT, and RD. So in this case, RD will be S0, RS should be S1, and RT should be S2. Because we know that this is the RS is the source number 1 or operands number 1, which is this. RT is the operands number 2, which is this. And RD, that is the destination address, which is this. Fine. That's how we can, by the way, whenever we write code, as a programmer, we just write this. Okay, we don't need to worry about this. We don't need to worry about that. You just need to write it this way, then the assembler and the processor will identify it and then do it in their way. But we need to know that. We need to know that. Not just, okay, we don't care about whatever the processor is doing, because it is very close to the hardware. So whenever you write the code, you must visualize, you must know that how the background process, the processor is working. Right, that is the one of the difference between low-level and high-level language. Whenever you write any high-level language, you don't really care how the processor is working. You just need to care, okay, I have to add two numbers, so I just write this, A equal to B plus C, that's it. Rest of the task will be done by the computer. But whenever you write code in assembly language, in this format, low-level language, you must need to care about all the registers, the size, the code, the formats, how they are doing it. So we need to care about everything. Because we are working very close to the hardware. That's why. You might be thinking, what is the necessity of that? Yes, we need it because whenever as a user, for example, we are a user, right? We just need to know this one. We don't need to know anything. That's why we are using the computer as a user. But whenever you're as a designer of the computer, or if you're an architect of the computer, in that case, we need to write this kind of code. Remember, generally the user of the computer or user of the device don't write this code. For example, your IoT device. For example, your robot. For example, your smart device. If you are a developer of that, or if you are an architect of the device, then you have to read this code. You are not a user. You are the developer. You are the architect of that. Fine, that is one thing. Another thing is whenever you use the high-level language, although other part you are actually a developer, but still generally you're just using that high-level language code as a user, because rest of the task is done by the compiler or the other parts of the computer. You don't need to actually worry about it. If you are not that much deep level programmer, sometimes it is also needed whenever you are working on high level language. And if you are working on very close to the computer, in that case, you also need to consider, although you are using or writing high-level language. It depends on your requirements, it depends on your work. But generally, whenever you are writing a high-level language, you're just working like an ex-user. But whenever you write a code for a low-level language, you are very close to the hardware. You are actually working or writing like an architect of that device. Because generally we write assembly language code, especially for hardware device, most of the time. Fine, so that is the difference. That totally there are two different branches. Perspective is different. Sometimes we write the equivalent code. For example, in this case, we write the equivalent code like this, just to give you the idea how it works, because we are comfortable with high-level language. We are not comfortable with low-level language because we don't do it regularly, but we do high-level language regularly. That's why every time they give the example or equivalent example of high-level language for your better understanding, nothing else. Okay, and one student was asking me that is it mandatory to write this kind of equivalent code? It is not mandatory, it is your choice. If it is not written in the question, then you have to write the code, unless it's written in the exam question. In other cases, you can explain your way, no problem. Let's say I ask you that please explain this code regarding the MIPS processor. Okay, so it is your choice that how you're going to define or how you're going to describe the code. Fine, so it is your choice, no problem. So it's not always mandatory. You have to write the equivalent C code. It's your choice, if it is not written in the exam. Fine, so that is our three different types of instruction format. Here they have discussed it, but very briefly. I will upload this file so that you can see and so that you can have an idea. You can visualize that how actually it's working. Any questions so far about these three formats?
No, sir.
Okay, anyone else think about it? Any problem? Don't ask me that how the question will come in the final exam. There is different story. But do you understand the fact, the topic? If you understand it, it doesn't matter how the question will come. Don't worry about the question. Think about the topic we have just discussed. At least you have an idea. I know it is not really possible to understand everything what I have said, but for many of you, in that case, I suggest you that you read the book properly. They have written nicely. You can read it from here. I will upload it into the Google Classroom now. You can read it from here, or you just write the or have the Google instruction NIPS instruction format. You can see thousands of pages. If you just write NIPS instruction format in the Google, you can see thousands of pages where they will show you. That's how I found this one, by the way, by Google it. Because I was really not happy the way they have described here, very, very short. Right, because they have written RS, RT, RD, SA function. What does that mean? They have not discussed it here. Fine. So it is, and there no, for this chapter 13 there is no video, so it's not needed. It's all right. So either you read the book, you read it from here, or just Google it, please. It's very common. So you will find so many things in Google. Okay, so please study yourself. So last part of this syllabus is we are going to do very basic coding. Very, very basic coding. Although there are so many other very difficult coding ahead of this on the other chapters, but we are not going to do that. Remember one thing, that for your convenience and thinking about you, I have reduced the syllabus. My plan was to describe more, and I requested my other colleagues to do the same. All right, because it's maybe you are struggling, maybe there's some problem. So there should be no excuses during the final exam or before the final exam that is very difficult, you don't understand, or I have not explained it properly. I have asked during the last 3 years 1,000 times, do you understand? Do you understand? Is there any question? Only few of you actually ask me question. Rest of you are totally silent. You never ask me any question. You never answer me any one of my question. There are so many students in your section, never talk to me in this whole 3 months. Remember one thing, please, that hopefully we will open in October. There is a meeting between all the vice chancellors and with the government. So if they agree, for all the public university will open very soon, first or second week of October. Private university, they have not decided yet, but it will be likely the same, second or third week of October. It will open. That means maybe at the end of the October at best. So there is a huge possibility that next exam, right? Let's say the first term exam or midterm exam in the next semester will be on campus. Probably. I don't know. I'm just guessing. Probably. So the way you are actually studying is, please try to change it. Try to interact with the classes. Although this is the second last class of this course, maybe next semester we will start online classes. We will start online. Maybe we will not start on campus next semester. We will start online, But maybe after some times of online classes, we need to go to the campus and start our on-campus study. I have requested you, I have suggested you so many times previously that please try to change the way you are studying online. I know many of you currently in this class actually not doing the class properly. As I said, you are not doing the class. I don't know how many of you actually sitting on a desk or table with a pen and paper with a book and doing the class. I don't know how many out of 29. It's very sad. We are 44 students, including me, it should be 45. We are now here, only 29. Only 29, that means 16 absent. 16 of them just absent. They are not in the class. And 28 of you, I'm not sure how many of you are on the desk in the same way you are doing the class on campus. Like properly, you are sitting somewhere, you have a pen and paper, and you take notes, you are studying or you're reading your book or something like that. I don't know how many. I have a doubt, it's not more than 5. I have serious doubt, not more than 5. Just think about it. You are not watching like drama on YouTube, or you are not watching or having an informal video call with your friends or relatives. It is a serious class. And most of the topic you have not heard it before. And you have only 3 days left. 1, 2, 3 days left before your final exam. Think about it. Ask yourself what you are doing. And please also ask yourself that you almost do nothing, you almost study nothing, you copy paste, you're cheating, and then at the end of the semester, whenever you have a bad result, what you do? Blaming me rather than yourself. So please change your habit. All right. Please change your habit. Try to learn something, otherwise it is difficult. I'm really sorry to say that if you cannot, prove that you have the minimum required knowledge about this course, very difficult to get marks from me. Not only from me, for everyone else in my department. So please study. All right. I am actually discussing so difficult topics, but nobody's asking me anything. Maybe you have understood everything or nothing. Anyway, please study, all right? So please study and be serious. We have only 3 days left. I don't know you are worried about your final exam, but I am really worried about your final exam. Seriously. Every time. I always thinking, my God, 18 is my exam. I always say that 18 on 18, I have exam. I don't say my students has exam. I said, I have exam. Because I am equally responsible. You still have time. You still have time. Do the classes properly. We almost finished this class. We have 1 more classes left. Do the study properly. Okay, study something, learn something. If you can prove at least the minimum knowledge you have, if you can prove that by writing in the answer script or during the Bible or in the assignment or everything, that you have the minimum knowledge, trust me, I give more marks generally than what you deserve. Although it is not right. Higher authority told me that not to do that. Whatever you deserve, you should get that marks only. If I do that, 72 was meter. If I do that, the instructions I have, then 92% will fail instead of 72. But I don't do that. I will not do that as well. If you deserve 5, I give you 6 or 7. Just for an example, So please, okay, I'm trying everything for you. Please try something for yourself as well. Other first mail. Most of you, many of you got 20, 30, 40, 50, both of the exams. First term and midterm. Very sad. Very difficult. Whenever you got 20, 30, 40 in the first term and both, it will be so difficult to go first term and midterm. Finally, so you have got on 20, 30, 40. You can calculate yourself. Okay, it's the last request. So we have only one task left. Anyway, let us continue and finish answer. So we are going to use only one instruction to move or load the data. For example, LB, we use LB whenever we try to load byte. LBU unsigned byte. LH half word. LHU unsigned half word. And LW is load word. Okay, so if you want to transfer the data, depends on the size of the data, you can transfer this or load this one, whatever you say. Fine. Do not worry about this. These are pseudo instructions by the assembler. We don't need to consider at the moment. Fine. We just need to know this. LB, LBU, LH, LHU, and LW. Example is this, the address, which address you are going to store or you are going to transfer, and that is the destination register. Either is LB, if it is low, it is byte. If it is unsigned, then it's LBU, something like that. Okay, so very simple and basic one. Don't worry about this explanation. These are not your concern or our concern, right? You just need to know this and this table. Just for an example, right? That going to do for arithmetic instruction, we already know addition and subtraction, right? We have discussed several times. So in addition, of course, we have 3 operands, one and source 2 will be added to each other, then store it into the destination register. We have 2 more other types of register, addition, which is that U and add I. This is add I, it is an integral, then we write add I. We have another one which is called add U, add U. What is add U? Very simply, whenever you add these 2 numbers, if there is any overflow happen, okay, overflow happen in this or instruction. Overflow means if you add 2 numbers, yes. Right. So in that case, you have a problem because there will be an interrupt and the processor needs to take care of that interrupt. But if you are using add U, no overflow exception is needed. That means in that case, if there is an overflow, so your processor, your procedure will not stop for this error. It will handle it by itself. Okay, so that is the difference between add and add U. And add I, as I said, if one of your value is immediate value. Like we have done, we have an example like this one. This one, add I. This is an example of add I. Fine. This one, add I. This is an immediate value. Here the immediate value is 4. And P2 and S3, these are destination and the source 4 and I. Right? Okay, so that is the addition. Very simple. We have very simple source 1 and source 2, and we know that the register of source 1 minus register of source 2. Remember, whenever you write R source 1, that means the content of this register, right? Content, because these are variables. Content of this register. So content of the register source 1 minus source 2, and it will be stored into the destination register. Very, very simple. And same as the case, if there is any exception. Fine. Same as edu and stuff. Okay. We don't need to know this one because it's not needed, because it's a serious. Don't worry. We need to know the basic about subtraction and addition and division. So that will be our. Oh no, we have another one after the multiplication and division. We have the logical instruction. All right. So multiplication is very simple. In this case, we are using two operands, number 1 and number 2. And after doing the multiplication, remember in the 6 types of processor, what we did after doing the multiplication? In 6 types of operation, Intel processor, what we have done after doing the multiplication, where we store our data.
Estimation.
Remember one thing, yes, remember one thing, this is 16, 32 bit and that is 32 bit. So whenever you multiply 32, your result is 64 bit, right? 64 bit. Same as the previous one. What did we do?
Sure.
Taking the data limitations.
You don't remember about the multiplication? Whenever you do 8-bit by 8-bit multiplication, how do you store it into the result part? You have two. You have two.
Course.
You have two registers, AL and AH. Right. So the lower part is stored into the AL register, and the higher part of the result will be stored into the AH register. That's how we store 16-bit, right? Because AL is 8-bit and AH is 8-bit.
Sir. Yes.
Right. So it's the same way. It's the same way. Same thing. Same perspective or same technique. This is 16. This is 32-bit. That is 32-bit. So when I multiply, we have maximum 64-bit. So we need a space of 64-bit. How we can do that? We actually using LO and HO register. Remember, these two are special purpose register. Remember, we have 3 types of register. That is the third type. Low register and high register. So obviously, the low register will store the lower part of the result, and HI store the higher part of the result. It is written here. Okay, because LO register is 32 bits, HI register is also 32 bits. Fine. So whenever you multiply these two numbers, right? So the result will be stored in these two registers, LO and HI. Fine. That's how we do the multiplication here. Same way we do the division here as well. Division. Source 1 and source 2. We consider that source 1 is the dividend, which number you are actually dividing. And source 2 is the divisor, by which number you are actually dividing. So source 1 divided by source 2. That's what it means. Now the question is, after doing the division, after doing the division, how many results do we have?
We have two results. One is quotient and another is remainder.
Exactly, correct. So whenever you do the division, we have actually two results. One is the quotient, that is the result, and another one is the remainder, right? So we also need two places to store this remainder and the quotient. Same way, LO register, whenever you do the division, LO register receive the quotient value and HI register receive the remainder value after the division. Fine, you understand? That's why if you think about, or if you look at the register previously, they said multiply and divide registers. That's why they write this one. Although the name of the register is the special purpose register. Fine? That is the reason. Low and high. So Maya Islam come at 2 o'clock for attendance. No problem. All are okay. Keep attendance. No problem.
Sir.
Yeah.
So in addition and subtraction, we use source, but why not in multiplication and division?
We use source. Look. Source 1, source 2.
Sorry,
So,
sir, destination.
oh, we don't have destination here because in the, for example, after the division, we have two answer, right?
Yes, sir.
So we need to have two answer. We have to use two register for storing the data, right?
Oh, yes, sir.
Yeah. So it is not possible, right? According to the instruction format, not possible.
Sir, but in div user, there is a destination.
Where we are not using any other. These are the pseudo instruction for by the assembler. Alright, so we are not using, because these are different. That's why I told you previously that we are not using this pseudo instruction. Okay, this is by the assembler.
Okay, sir.
Good question, by the way. Okay, why we cannot use another register? Because we actually have two answers. That's why in the division we cannot do that. And also in the multiplication, whenever you do the multiplication, we cannot use one single register because the result is the double the size. Whenever you have double size result, so there is no register which can store 64-bit result in this MIPS types of processor, because all the registers are 32 bits. So in the multiplication, it is also not possible. That's why they have separate types of register, special purpose register, only for these two. That is the basic reason.
Sir, one more question.
Sure.
So in MIPS type, sir, we can do only 30-bit
Yes.
multiplication, division, subtraction, addition.
Yes, because it
Okay,
is
sir.
not possible. Obviously, it is not possible more than 32 because this processor is 32-bit. R2000.
Less than 32-bit?
Yeah, MIPS R2000 is 32-bit processor, so it is obvious that you cannot do more than that. But if you are using MIPS R4000 or more than that, then you can do 64-bit multiplication.
Okay, sir.
Because it is the same as the Intel processor as well. We can do maximum 32 bits, what we have seen previously, because the processor we are talking about previously, Intel processor, those are also 32 bits, not 64. But if you have 64, I told you this book written like 15 years ago. So if this is the current book where they're actually using the 64-bit microprocessor, obviously you can multiply it by anything within the 64-bit, of course. Okay, any other question? Thank you for asking question. Any other question? We have last topic, which is the logical operation. We already know what is the logical operation, so it is very simple as well. Logical AND. Okay, AND I, because it is an immediate value. One of the source is immediate, that's why it's AND I, or and or I, not or XOR and XOR I and NOR. Fine, so these are the example we already know. It's very simple, that's why I'm not going to describe this one. And look at the example here. Can anyone guess or explain what does that mean? By the way, that is the end of our entire syllabus. After that, we are not going to discuss anything. So can you guess what does that mean? You know it. If you just think about it.
It means subtraction, I think.
Look at it properly. This is a NOR. That means opposite of OR. This one. And look at the formats, destination, source 1, source 2. Right? Destination, source, and this one. What does this mean?
Register, sir.
Of course, it is a register. Which register? It is a register, yes. Which one? $0. Which register it is?
General purpose register.
Of course, general purpose register. But we have 32 register. Which one it is? First one.
Yes, the first one.
First one, right? So can you remember? Yeah, the first one. Can you remember what is the responsibility of the first register? Remember, we have two reserved ones, first one and the last one. This is the first register, $0. First register, 0 register. What is the responsibility of this? Very simple.
So moving data from...
No. Think about the first register or the 0 register of the MIPS processor. What is the responsibility? Is actually, you forget it. Actually, this 0 register or the first register, they always store 0. That means you have never checked this one. This one. It's actually constant 0. The value here is all 0 in this first register. It is also written here. Register 0 is the hardware to the 0 value. This register often used as a source register when a 0 value is needed. Simple. Fine. That's why whenever you try to explain the code, that's why I'm asking that, can you explain the code? If you know the fact, it is not that much difficult to explain. That means we are doing the NOR operation, opposite of XOR, with this source, whatever the value inside, with 0, because this is all 0. That means this one will be NOR with 0, and then the result will be stored into this register. That's what it means. Fine. Not difficult. It is really not difficult, but you just need to study a little bit and try to or able to relate one knowledge or one topic to the other, because everything is interrelated. Okay, except if you are doing like blind memorization, that's a different case. But if you try to understand what actually we are discussing or whatever, the chapter 12 and chapter 13, what is the relation, it is so simple to explain. I suggest you do this kind of study. Try to relate whatever we have discussed so far and whatever it is written in the book. Fine. So it is already 2:08. We're almost finished the class. Any question? No. If you have any question, tomorrow we have the last class before the exam, which is 15th Wednesday. Your exam is on 18th. So if you have any question, any problem, or any issues, let me know tomorrow. Tomorrow we are going to revise our previous chapters. Let me give you the attendance in the meantime. Your section C, today's 14. All right, so CSC-197 section C, Shakil Ahmed.
Present, sir.
Nur Rahman.
Present, sir.
Saidul Islam.
Yes, sir.
Moinul Islam. Email Shorter.
Yes, sir.
Fahri Ahmad.